Number system, grade 10, third unit. So under this number system, we have to talk about binary number system, octal number system, decimal number system, hexadecimal number system. Mainly, the binary number system is used to store data within a computer. So accordingly, the number system used for the representation of the data in the computer. So here we are going to talk about how we can convert these number systems among these. Right. First, you all can see binary number system. If we get, there are only two numbers, that is 0 and 1. So octal number system, if we get 0, 1, 2, 3, 4, 5, 6 up to 7 numbers are there. All together you all can see here there are 8 numbers. Decimal number system, you all have experience, that is about the 0 to 9 all the values. The hexadecimal numbers, if we get, there are 16 numbers, but it is, you all can see it's a bit different. So this is starting from number 0 to 9 with the numbers. So then A represent 10, so B represent 11, C represent 12, D represent 13, E represent 14, F represent 15. All together there are 16 numbers are there. So we will see how we can work with these number systems. Right. So what we are going to learn it here, first we are going to talk about how we can convert decimal numbers into binary. Right. So we are going to learn about how to convert decimal numbers into binary and the binary numbers into decimal. So after that we are going to talk about how we can convert any decimal numbers into octal. So octal number system into decimal. Next we are going to talk about how we can convert decimal numbers into hexadecimal and the hexadecimal into decimal. After that we are going to talk about how we can convert the binary number into octal. So the octal numbers into binary. So after that we are going to talk about how to convert binary numbers into hexadecimal. So hexadecimal into binary. So finally we are going to talk about how to convert octal number into hexadecimal and the hexadecimal numbers into octal. I think better you copy this one, this small plan, what we are doing under this unit, okay, in your book. Right. The first we are going to talk about how to convert decimal number into binary. Write the topic in your book. After that we'll get experience about this one. We'll get a simple number. We'll try to convert this number into decimal. What we are going to talk about here is converting the decimal numbers into binary. Right. When you are writing about any decimal number, you can write it as example 100 in this way, or either writing base below of that, that is 10. So any binary number, when you are writing 1, 1, 0, if you think, so it is compulsory to write the below, the base is 2. If you write it any binary number like this without mentioning the base, so it will be a wrong number, it will get it as a decimal number. These are the basics of the decimal and the binary numbers. Here we are going to talk about how to convert decimal number into binary. We'll get a simple number, the number 9. Okay, so we need to convert this number 9 into binary. Right. So this when you all want to convert that the decimal number 9 into binary, the step is you all need to divide that 9 by 2. You need to write it like this. Okay, we are going to divide by 2, and the simple rule you can use for this one, that is equal to 2 and greater than to 2. Whatever the number is here is equal or greater than to 2, we need to divide. So to make it simple and understand, in this side I will do a small rough work like this. Normally you are dividing in this manner. So if you divide it like this, okay, then 2 to the power of 4 is 8, the remaining value is 1. Like normal division, we are not going to divide this 1 by getting a 0 here. So this 4, the number, you need to write it here, and the remainder is 1. By drawing a line, you will need to write the 1 in this side. So after that, you can see this number is greater than to 2. So then you have to divide it again. So then if we do a rough work like earlier, so 4 is the number, so that is 2 to the power of 2, that is about 4, and remaining value is 0. So then I will write that 2 here, okay, the remaining value is 0. So after that, so whether we need to divide this one again, yes, because it is equal to 2. So then I will write it like that, okay, so that will do a small rough work. So then it is about 2 to the power of 1, that is 2, remaining is 0. So then the number is here 1 and the remaining is 0. And we completed division of this, converting this binary number, sorry, decimal number 9 into binary. So then the final answer, how you can write, okay, this side to the bottom to top. Okay, so the first one I will write it here, that means this one I will write it here, and the second 0 I will write it here, 0, and this one I will write it here. So then definitely you need to write the 2. Okay, this is how you all can convert the decimal number 9 into 2. Please copy this in your book. Okay, we'll try out another number. Okay, we'll get another number, that is 20 decimal. So we are going to convert into binary. So how we can do this? Okay, we'll divide it by 2. So the value will be here 10, the remaining is 0. You can understand. So after that, we'll divide it again, and then it will be 5, remaining 0. Again we need to divide it again because it is greater than to the divisor. So then after that, the number will be here 2, the remaining is 1. So again we need to divide. So then number will be here 1 and remaining 0. So then it's a end of division. So then we can write the final answer as 1 0 1 0 0 2. This is the second example, that how you can convert this decimal number 20 into binary. Right, we'll try out another number. Okay, we'll get number 50. Okay, that is decimal. So we are going to convert into binary. So you can write the number. So we are going to divide it. So after that, the number will be here 25, and the remaining is 0. So after that, if you divide 25 by 2, it will be about 12 and remaining 1. So after that, it will be, the number will be 6, the remaining is 0. After that, we have to divide it again. The number will be about the 3, remaining 0. So after that, if you divide this 3, so then the value will be here 1, remaining 1. So the final answer is 1 1 0 0 1 0, 2. Okay, I think you understand how to convert any decimal number into binary. Even whatever the number, you can divide by 2 and you can get this answer. And you need to write, when you're writing, you have to be careful. Don't forget to write the base 2. Okay, the next topic is about how we can convert the opposite of this one. That means how we can convert how to convert binary number into decimal. Please write this topic in your book and I will show you how you all can convert any binary number into decimal simply. Okay, and what we are going to do it here is converting the binary number into decimal. Okay, we'll get a binary number that's about 1 0 0 1 2. What we are going to do is we are going to convert this one into decimal. So how you all can do it, you can write the answer by keeping a little bit more space. Likewise, then so you need to write under this most right number 2 to the power of 0 into this number, that is 1, plus 2 to the power of 1 into 0. The 0 came from there, here this number. So after that 2 to the power of 2 into 0, the 0 is this one. After that 2 to the power of 3 into 1. Right, the first part answer is it's about 1, and you can understand 2 to the power of 0 into 1, that is 1. So then here 2 to the power of 1 into 0, the number will be 0, and 2 to the power of 2, if we multiply by 0, number will be 0. 2 to the power of 3 is 8, 8 into 1 is 8. Then finally you need to add these all the numbers. Then the answer is it's about 9 in decimal. This is how you all can convert any binary number into decimal by using 2 to the power of value. Okay, we'll try out another number. Right, the next number is 11012. Right, I will write the value by keeping a little bit space, 0 and 1. Then here 2 to the power of 0 into 1 plus 2 to the power of 1 into 0, the 0 is this one, plus 2 to the power of 2 into 1 plus 2 to the power of 3 into 1. So then here the value is 1, you all can understand. So here this place is it's about 0. 2 to the power of 2 is 4, 4 into 1 is 4, plus 2 to the power of 3 is 8, 8 into 1 is 8. So the final answer is about, if we add this all, it's about 13, it's 10. Okay, this is how you can convert this binary number 1101 into decimal. We'll try out another one number. The next number will take 110110 We are going to convert this one into decimal. So then 1 1 0 1 1 0. Then you all can start it with the 2 to the power of 0 into 0 plus 2 to the power of 1 into 1 plus 2 to the power of 2 into 1 plus 2 to the power of 3 into 0 plus 2 to the power of 4 into 1 and 2 to the power of 5 into 1. So this one value is here 0, so this value is 2 and 4, and here 0, and 2 to the power of 4 is about 16, then 2 to the power of 5 is about 32. So if you remember this 2 to the power of value, your calculation speed will be very fast. Okay, keep it in your mind, and you don't want to calculate and find the answer. Okay, so then the sum of these all the numbers is here is about 54 in 10. So this is how you all can convert it, the binary number 110 into decimal. Right, I think you got the idea. Now this is the end of how to convert decimal into binary and the binary into decimal. Using similar technique, we are going to learn about other number systems. Okay, next we are going to talk about how to convert decimal number system numbers into octal. Okay, write this topic, children, how to convert decimal number into octal. Right, we'll see how we can do the work. Okay, now what we are going to do is we are going to convert these octal numbers, decimal numbers into first decimal numbers into octal. You should have an idea about octal number range, so I will write it here, then it will be easy for you all to do the work. 0, 1, 2, 3, 4, 5, 6 and 7. Right, the 0 to 7, all the numbers are there in the octal number system. We'll see how we can convert the octal number decimal number 6 into octal. Right, now here also you can write these this type of small method, which is equal to 8 and the greater than to 8, the given number is equal to 8 or greater than to 8, then you all have to divide it again. So this case you can see the given number is 6. The 6 is a decimal number as well as it is available in the octal, and it won't meet this one, it comes the false because the 6 is not equal to 8 and the greater than to 8. Because of that we are not going to divide it again. Okay, I have seen it, some kids, because they don't have experience, they have divided by 8. You don't want to divide by 8, it will be wrong. So then you need to do is what you apply this rule and see whether you need to divide it. We are not going to divide this 6 because it is not equal to 8 or not greater than to 8. Then you can write the answer regarding the first example, that is 6, 8. Okay, and when you are writing these octal numbers, it is compulsory to write 8. Okay, if not it will get as a decimal number. As example, if you write just 6, it will get it as a decimal number. Okay, then don't do that mistake, keep it in your mind. If there is octal number like binary number, it is must write the base 8. Right, this is your first example. And one of this number, if you will get it as a decimal number to convert into octal, okay, that means 0 to 7, even 7 comes, 2 comes, 3 comes, don't divide it, just write the number with the base of 8. Right, we'll try out the second example. The second number will get it as 8. Okay, that is decimal, you have to convert into octal. Now do we want to divide this one? Yes, it is not in the octal range, as well as it is equal to 8. Then what you will have to do is we are going to we will divide, you need to write the number here. Okay, we will divide this one by 8. So then this is a simple number, you can easily understand. So we'll do a rough work and get idea if that is difficult for you all. So it is about 1 will goes to 8, it is about 8 remaining 0. So the number we get it is 1 and 0. So as a final answer you are writing this 10 in here with the base of 8. This is the answer for after you converted the decimal number 8 into octal. I think you get idea. It's easy. We'll try out another example. The next number is about the 15. Okay, we'll get 15. We'll convert it into octal. So this number is greater than to 18. So then we can divide by 8. So after dividing this one, the only one will goes here. So after that the remaining is 7. So then you can write 1 7 in octal. Okay, this is how you can write the number. And as a remainder, if you divide it correctly, you will get one of these numbers. If comes like 8 here as a remainder, so then your division is wrong. Okay, you have to concern about that. Okay, we'll try out another number. The next example we'll get number 35. Okay, decimal we are going to convert into octal. So what will be the how we can divide and get the answer? So we'll write 35. Okay, we'll divide by 8. So this case you need a 4. Okay, that is about the 32. So then remaining is 3. So 8 times 4 is 32, the remaining is 3. So this 4 you don't want to divide it again, because it is a not meet this it is not equal to 8 and it is not greater than to 8. So as a final number 43 in 8 you can write. Right, I think you understand after converting 35 into octal what is the answer is. Right, and we'll get another number. We'll try out that. We'll get the number 75, right, decimal. So we'll convert it into octal. 75, we'll write it like this. So we'll divide by 8. So then it's about 8 times 9. So 8 times 9 is about 72, then remaining 2. So after that 9 we need to divide it again, because it is greater than to 8. So after dividing that one, 1 and 1 will come, the 8 times 1 is 8 and the remaining is 1. So if this way for you all to hard, that you can do your rough work like this. Okay, the 9 and 8. Okay, so here 8 remaining 1 like this, as I shown in other converting cases, right? And how to write the answer? 1 1 2 in 8, right? If you have a more numbers here bigger than to 8, that you can continuously divide it until you get the this rule will false. Okay, right. This is how you all can convert any decimal number into octal. Right. Next we'll talk about how we can convert any octal number into decimal. Right. So write this one in your book, how to convert octal number into decimal. Right. What we are going to do it here is converting octal number into decimal. So how we can do this? It's easy, right? We'll get one example. We'll get 11 in 8. So as in converted binary into decimal, this case we are writing the number by keeping space like earlier. Now here we need to to find answer, you need 8 to the power of value. First you are starting from the 8 to the power of 0 into 1 plus 8 to the power of 1 into 1. So here 8 to the power of 0 into 1 is 1, and 8 to the power of 1 is 8 into 1 is 8. So the final answer after adding these two numbers is 9 in 10. This is how you all can simply convert any octal number into decimal. Very easy, right? Copy that one in your book. Okay, we'll try out another example. The next example is we'll get 26 octal into decimal. So I will write it here 2 and 6, 8 to the power of 0 into 6 plus 8 to the power of 1 into 2. Here 8 to the power of 0 into 6 is 6 plus, and 8 to the power of 1 is 8 into 2 is about 16, and after we add these two numbers the sum will be 22 in 10. I think you got the idea how to convert this one, and we'll try out another one example at this. Right. The next number will take as 100 in 8. Okay, so 1 0 0, then 8 to the power of 0 into 0 plus 8 to the power of 1 into 0, 8 to the power of 2 into 1. So here the value will be 0 plus 0 plus 64. 8 to the power of 2 is 64. The final answer is, after adding these all, 64 in 10. Right, this is how you all have learned it, how to convert octal number into decimal. Write this example in your book and practice this all. And next part we will learn another few part within the number system.